Hello friends, today we're going to solve longest Univalue path. Given a binary tree, find the length of the longest path where each node in the path has the same value. This path may or may not pass through the root. So let's see in this example, um, so you can just start from this route and then travel to this node. And we have this path which consists of three edges, which is the longest path. And also we can consider this path for, okay, so this path also having three edges in it. You can also see there is one more path which consists of one, two, three, four, five edges, right? Actually, for this example, this is the solution, right? So this is the longest uni-value path. So we just have to return the length of the longest uni-value path. Okay, so let's see how do we solve this problem. Uh, so I'll remove this. So I'm going to return max length, and I'm going to design a recursive function so that we can traverse from root to deep, right? So I'll name it as find. So this function can accept one node and it can accept one parent, corresponding parent value. Okay. So in order to include this node in the path or not, so we need the parent's value to compare with. So let's write some base cases here. So if there is no node, just return 0. And if there is no left or right child, which means this is a leaf node. Okay, so in this case, so what we can just do is just return if node.value is equal to parent value. Okay, then just return 1, meaning include this leaf node in the path. So else just disconnect this path, just disconnect this node from the path. So if it is not the leaf, then we have to take some decisions here what to return. So first we can validate the current node. If the node value is equal to parent's value, then we have to include this path, right? So we have to uh, include this node to the path. So we can just return 1. Also, we have to have the left subtree length and right subtree length as well, right? So what we are going to do is, so if let's say we have left and right subtree has some path lengths. So when we validate, okay, this node is going to be, continuing to the parent's path, then we are just including this path, and also we are just going to, take the maximum among left and right. So we have just picked up the maximum path length from left and right, okay, among left and right. So if that is not the case, just disconnect this node, okay, just return 0. Okay, so we are going to recurse for left. So find node dot left when current node's value as its parent, and recurse for right with current value as its parent. So having a non-zero value means that this is trying to connect to this, right? So we are just having two values trying to connect to the current node. We can just pick up the maximum among them, right? So both can have some path length with the same value. If the left or right is 0, means that is going to disconnect, so we can just discard it, right? So either of this can have path length. So if we don't have any left length and right length, which means that there is no subtree joining this node, we can just return 1 from this node because this is the current node which is having the same value as parent. So we can just include this node alone, right? If it is not that case, we can return 0, we can disconnect, but also we should not simply disconnect the entire subtree to the parent, but we have to consider these left and right values to update the max. So irrespective of we are going to connect to the parent node or not, we have to just update the maximum length because left path length or right path length can be, can have some value which can be more than. So left have some value or right can have some value, we have to update the maximum value. Okay, right? Irrespective of we are going to, connect to the parent or not. So let's update the max length here. So update max length. We are going to compare the value with the left and also the right. Okay, because so left length non-zero value has some. So for example, take this case. So this can return a non-zero value, which is one, and this can also return a non-zero value because these are connected, right? So if that is the case, just add it because this node is also going to be included to the path. So just add left and right. So that can be combined as one path, right? From the left, some count, and from the right, there is one count. So we can just add them to include with the current node. Okay. So we include that path. So and update our max length. That's where we update intermediate paths in any part of the binary tree. Okay, if the current node is going to be part of parent path, then we have to just include and we have to ignore the smaller path, right? So we are going to take the left or right, which is the longest path, and we are going to continue with the parent. Okay, so else, if at all we are not going to continue with the parent, just return 0, but we should update the max length. Okay, so we are disconnecting to the parent, but before that, we should not forget to update the max length, right? So hope it's clear to you guys. So maybe we can just call this and test it out. So find for the root, and the parent value of the root is just -1. Try to run this. Okay, cool. That works for this test case. Yeah, so what is the maximum length? Uh, yeah, 2. This one, right? This one. Cool. So you can just submit this. Okay, what's this? Cool, works. Hope you enjoyed this video and thanks for watching.